Question 2.1. State what is meant by the internal energy of a gas. The internal energy of a gas or anything is the sum of the kinetic and potential energies of the particle, atom, molecule that moves at random in a gas. So this is the internal energy is equal to the kinetic energy due to temperature and potential energy. Question 2.2. Absolute zero of temperature can be interpreted in terms of the ideal gas laws or the kinetic energy of particles in an ideal gas. Describe these two interpretations of absolute zero of temperature. Absolute zero of temperature in an ideal gas law is PV equals nRT, and when T equal to 0, PV will be 0. In kinetic theory, the kinetic energy is 3 over 2 kT. When T is 0, kinetic energy is 0. Question 2.3. A mixture of argon atoms and helium atoms is in a cylinder enclosed with a piston. The mixture is at a temperature of 310 Kelvin. Calculate the root mean square speed of the argon atoms in the mixture. Molar mass of argon equals 4 times 10 to the power minus 2 kilogram per mole. We got the temperature. We're looking for the root mean square speed. The molar mass is 0.04 kilogram per mole. The kinetic energy equals 3 over 2 kT. We also know kinetic energy is I half mv squared or I half mc squared, where c is equal to v. And that equals 3 over 2 kT. Divide both sides by a half, or cancel the a half on both sides. So mc squared equals 3 kT. Divide both sides by m, c squared equals 3 kT over m. And you need to square root both sides. So c equals root 3 kT over m. This m is a mass of 1 mole. This mass is a mass of 1 molar mass. That meant there are 6.023 times 10 to the power 23 molecule in there. So we want to find the mass of 1 molecule, which is that one. And so what we do is divide the mass, molar mass, by the number of molecule in there, and then we get that. So now what we need to do is plug in those values into here, and then we get the speed, the root mean square speed, to be 440 meters per second. 2.4. Compare the mean kinetic energy of the argon atoms and the helium atoms in the mixture. Well, the kinetic energy is 3 over 2 kT. They will have same temperature. That meant same mean or average kinetic energy. Question 2.5. Explain, in terms of the kinetic theory model, why a pressure is exerted by the gas on the piston. This is collision theory. Atoms collide with the piston wall and change of momentum occur. The piston provides the force, which is equal to rate of change of momentum. So that's F equals to m, change in velocity over change in time. The impulse Ft is equal to change in momentum. 2.6. The mixture of gases in the cylinder stays the same. Explain, using kinetic theory model, 2 changes that can be made independently to reduce the pressure exerted by the gas. PV equals nRT. By removing some gases, N will decrease. So that will go down if you remove some gases. If you reduce the temperature, the pressure will go down, because pressure is directly proportional to temperature. Root mean squared is small, and the change in momentum and change in force. Pressure is reduced and increased in volume. So if you increase volume, pressure will decrease. because pressure and volume are inversely proportional.